Hi, my name's Sanjay. I am a systems engineer at Cisco Meraki, and in today's video I'm going to talk you through how to resiliently extend your Meraki SD-WAN solution to the Azure cloud. Many of our customers are using Meraki SD-WAN to interconnect their branches, headquarters and data centers, but now looking to migrate some of their workloads to public clouds such as Azure and AWS. This video is a step-by-step guide to extending a Meraki SD-WAN solution to Azure cloud. I will show you how to spin up the virtual MX, which is the Meraki SD-WAN virtual appliance. I will then show a method of providing resilience by spinning up a second virtual MX and using BGP to provide routing and to ensure maximum uptime. And in typical Meraki fashion, this will be done simply in a matter of few clicks. One thing that I must add is that for this demonstration we're using the Azure root server, which is currently in preview mode from Azure, which basically means beta and shouldn't be used for production networks. If you want to add resiliency to your Azure environment connecting into Meraki SD-WAN currently, you should be using the Azure function. Full details and documentation of this can be found on the Meraki website. So this will be our starting point of the demonstration. We have Meraki SD-WAN environment already set up, which has a campus, branch and DC connections as per the diagram. There is also an Azure environment with a workload and VNet setup, but no connection to the SD-WAN. So let's jump into the demo. As you can see, we have a network already set up. We've got a couple of data centers here. We've got the campus network and several branches as well. We've got branch Manchester, branch London, but branch Sanjay is where I'm working from right now, and where I'm going to be doing the configuration from, doing my testing from. So if we jump onto branch Sanjay, we can see that there's an MX already configured and it's all up and working. We can have a look at the configuration from a VPN perspective, and we can see that it's set up as a spoke with 3 hubs configured, with data center A being the priority down to the campus appliance being the tertiary. I've also got a few prefixes there, all under the 172.29 prefix range, so we've got a couple of /24s that we're advertising across the VPN. So what we need to do is set up a new network for the Azure VMX. So this is going to be the setup for the configuration for the VMX actually on the dashboard itself. So first thing we need to do is give it a name. We'll call that VMX1-Azure, and the network type will be a security appliance, and that's it in terms of configuration for the time being. We'll create the network. We've already added the license in already, so dashboard knows that we haven't actually attached the physical device to it, so it assumes that it's going to be a VMX. Click on add VMX, and there we have it. That's the configuration done. The one thing that we do need to do is generate an authentication token. So this is the way that the VMX actually authenticates the dashboard to say this is who I am. I am the VMX actually for this particular organization. So let's jump into the Azure environment and see what we've already got set up from in terms of virtual machines. As I mentioned previously, we have got a workload configured on there. So there is a single virtual machine, which is the workload, and we've set up a virtual network as well. So that's VNet1. VNet1 actually has 3 subnets defined underneath it. Those subnets are the root server subnet, which we'll talk about later, the server subnet where the workload is actually sitting, and the Meraki subnet. And the Meraki subnet is where we're actually going to spin up the virtual MXs. Okay, great. Now we know what our Azure environment looks like. Let's see if we can spin up the virtual MX. What we need to do is go to Marketplace. Now, Marketplace is just an online catalog of pre-packaged applications sitting within Azure itself, and we can do a search for the Meraki VMX, and it should come up. And now if we click on Cisco Meraki and click on create, what we're doing is actually creating the Cisco Meraki VMX virtual machine. It'll take you to a wizard. That wizard gives you several options. First one is a subscription. I've only got a single subscription here. Then you can select a resource group. A resource group is basically a logical group of resources, making it easy to apply access control. I've already got a resource group already pre-configured. The region where the rest of my applications are sitting already is in East US. We need to give our virtual machine a name. I'll give it a name of VMX-1. And most importantly now is we need to paste in the Meraki authentication token that we got while we were setting up the network in the dashboard. Availability zone is important, so availability zone 1, each availability zone sits on different pieces of hardware, so if we spin up a second VMX it needs to be on a separate availability zone to stop that single point of failure. Now, virtual network we've already got pre-configured as we showed earlier, VNet1, and the subnet within VNet1, Meraki subnet is where we want to place this particular VMX. Now you can choose which VM size you want to run. I'm going to choose the smallest size possible because this is obviously only a lab. So I select that and we click on review and create. So we can review all the selections that we've just made, look through them. We'll have to agree to the terms and conditions. Once that's done, we can click on create. Now what this does is actually deploy the VMX. This usually takes a few minutes to do, and what I'll do is actually scrub through this when I'm doing the recording. As you can see, now the VMX deployment is complete and we can go to the resource and interrogate and see if everything's okay. Everything seems to be up and working, and we can actually pop in and actually see the virtual machine itself. So we can see the virtual machine is up and working, and we can see a public IP address has been assigned. If we go back to the dashboard, we see lots of green lights, which is always good. Which means that the appliance is actually registered to the dashboard, and the dashboard can actually see that VMX appliance. Now, a few configuration tests we need to do. We need to create this VMX as a hub so my spokes can get to it. A couple of other things that we do need to do. First of all, we do need to add that local network. Not sure if you saw that, but we had the local network actually within Azure of 10.0.0/16, so we just need to add that in to the configuration of this particular VMX. One other thing that we do need to do is, because we're running BGP from the data centers, that we do need to enable BGP so that it learns the prefixes from the data centers as well. If we weren't running BGP to the data centers, we'd be fine. There'd be no need to do that. So let's jump over to branch Sanjay and make sure the configuration is all okay on this side. So we've got site-to-site VPN, and we need to add the Azure VMX as a hub. So let's add that in, and we'll click save to that, and then we can check on the VPN status and make sure that that particular VMX is up and working. We can see that green dot next to VMX1, which is a good sign. Last thing we're going to check is the route table from branch Sanjay and see if we can see that 10 network, which is configured on the Azure network. So all good from that perspective. Green LED there as well. So all looking pretty impressive. So let's jump back into the Azure environment and make sure the routing's okay on this side. Let's have a quick look at the two virtual machines that we've got up and working and check the IP addresses. So the VMX is 10.0.1.4. and the workload that we want to try to get to is 10.0.2.5. So we just need to make a note of that, because what we need to do is set up the routing on the Azure side of the network. So first thing we do need to do is actually create a route table, and we'll add a new route table in because there's no route table existing on this particular network currently. And again, we need to apply the Azure subscription and the resource group, and we've got the resource group already pre-configured, and the region again is going to be East US, and we'll give it a name of Azure Meraki. We'll click on yes to create routes, and then we press create. And what we've just done there is create a route table, but the route table itself actually hasn't got any routes in it. So what we do need to do next is actually add the routes into the route table itself. So we click on our route table that we just created, click on routes, click on add, and basically we want to create a route back up to Sanjay branch. So as we showed earlier, Sanjay branch has got prefixes all in the range of 172.29.0.0/16, and the next hop is actually going to be the VMX that we've just created. And if you can remember, the IP address of that was 10.0.1.4, and we click OK. Now we've created a route. The route's created, the route table's created, but we actually haven't applied it yet, so we need to apply that to a particular subnet. The subnet where our server sits is the server subnet, and we can apply that route table Azure Meraki to that particular subnet. So now theoretically we should have two-way communication from the Azure environment all the way up to branch Sanjay and back again, with the addition of that user-defined route that we've just added within the Azure environment. So we can go back, just double check on that workload IP address again. So we can see that as 10.0.2.5, and that's what we'll try to get to. So if we jump over to branch Sanjay, we can click on tools over here, and then we can try to do a ping. So we click a source IP address of VLAN 250, which will be the 172.29.250 prefix, and we try to get to 10.0.2.5. Click on ping, and fingers crossed we should have connectivity between branch Sanjay and the workload which is sitting in Azure. And hey presto, there we have it, two-way communication from our branch all the way to Azure and back again. So we've just created a multi-cloud SD-WAN network in less than 10 minutes. So pretty impressive. So this is what we have so far. We have the Azure environment with a single connection into our SD-WAN. But what we find is as customers put more and more workloads into Azure, they want some level of redundancy or resilience actually for connectivity. And that's what we're going to do next. So what we're going to do is create a second virtual MX within our Azure environment, and we're going to use something called the Azure root server. So you can think of the Azure root server a bit like a BGP root reflector. What it's doing is actually taking the BGP prefixes learned via the virtual MXs and redistributing them into Azure environment, and taking the Azure prefixes and actually putting them back into the SD-WAN environment. So there's no need for those user-defined routes that we actually created last time on the Azure environment anymore. Everything's dynamically done via BGP. So the first thing we need to do is create a second VMX. Now what I'm going to do is actually scrub through this pretty quickly in terms of the recording, but it's pretty much the same process as last time. The only one thing to note is that when we actually create the availability zone, we're going to put this on a separate availability zone, zone number 2. If you remember, VMX1 was on zone number 1, so we are now on separate pieces of hardware actually within the VMX environment itself. We also create the VMX as a hub and do all the configurations that we did last time, and then we should be up and working. So we've got this exactly the same configuration for VMX2 as we have for VMX1. So the final thing I want to do is go to branch Sanjay and add VMX2 as one of my hubs for branch Sanjay. Click on save there. Now VMX1 and 2 are part of my hub environment from branch Sanjay. Now let's jump back over to our Azure environment, have a look at our VMX that we've just set up. So let's click on VMX2. And on VMX2 we can see that it's now got an IP address of 10.0.1.5. Now we have the two VMXs already configured on the Azure environment. Next thing we need to do is set up the Azure root server. Now the Azure root server is at time of recording in preview mode within Azure, which basically means kind of beta, but the configuration and the setup is exactly as we've described earlier, i.e. BGP to our two VMXs, providing redundancy, resiliency and prefix updates. So I've pre-configured the root servers on my Azure environment, At time of recording, it's a fairly manual process setting up these root servers, so I've not taken you through step by step, but I will put some detailed configuration steps right at the end of the video. But as you can see, the IP addresses of the root server are 10.0.0.4 and 10.0.0.5. There's actually two IP addresses on the root server for resilience, and we've got an AES number of 65515. So basically what we do need to do now is actually create some BGP peering from our VMXs to the root server. So as you can see, we're back onto VMX1, the configuration stanza, and what we need to do is actually create that BGP peering here. So what we do is click down to BGP settings, click on add BGP neighbor, and then we need to put the IP addresses on. So we've got IP address of 10.0.0.4, and the remote AS number was 65515, I do believe. And we put the eBGP hold down timer down as 180, which is the default setting, and eBGP multi-hop of 2. And we'll save that. And now we can jump over to VMX Azure 2. So this is our second VMX that we've just created, and we'll do the same here again. So we'll add a BGP neighbor and put the neighbor IP address of 10.0.0.4 and the AS number of 65515. Again, the same hold down timer and the multi-hop address. What I forgot to do on the other one was actually put the second IP address of 10.0.0.5, so I'll do that on this one. And I'll go back to Azure 1 as well and configure that second IP address on that Azure 1. So what we should have is BGP peerings between our two VMXs and the two root servers all configured, which means that there is no need for that static route. So the user defined route that we actually had on Meraki subnet, we can on the server subnet, we can actually remove. So we can remove that particular route table from that particular subnet, and now we are totally reliant on BGP doing the updates within the Azure environment. So if we jump back onto branch Sanjay, we should be able to still reach the workload server, even though we've actually removed that user-defined route actually on the Azure environment. So if we put 10.0.2.5, I believe it was the IP address of the workload server, press ping, fingers crossed, we should have some connectivity. And hey presto, we've got connectivity. So what we're doing is going back and forth back to our Azure environment, and we're actually using BGP to do the prefix updates. Now what we can do is actually jump onto the CLI of the root server just to make sure that we're actually understanding the prefixes and learning the prefixes correctly from the VMXs. So what this command is doing here is actually showing which prefixes were actually learnt from VMX1. So if we hit that enter button, we can see all these prefixes are actually learnt from VMX1, and on there you can see the 172.29.100 prefix, and you can see the AS path of 6505 prepended 3 times. And if we go into VMX2, we should look for the same route again. So these are the prefixes learnt from VMX2, and what we should see is an extra prepend because this is our 5th most preferred route. So as you can see here, we go to 172.29.100 and we can see the AS path prepended 5 times. So in terms of preference, we'll always prefer VMX1 while it's up and working. So what we can do now is let's try turning off VMX1. We'll shut down VMX1 and see if we can still continue to ping from branch Sanjay over to our workload server. So let's stop that particular VMX, check on our dashboard, and as you can see here, VMX1, there's a red light next to it, which means that it's down. Let's jump across to the appliance itself. So there'll obviously be a downtime while BGP converges, but let's see if we can actually get to our workload server and see if we can ping to it from our data network on VLAN 250. So ping 10.0.2.5 and see if we get communication. So this will mean that we're actually getting to it via VMX2 if this works. Press ping and hallelujah, we have connectivity. So over the last 20 minutes we've created a multi-cloud with an Azure environment with dual connectivity into our SD-WAN environment. We're using the Azure root server to propagate routes into Azure and to provide resilience. Please note that the Azure root server at the time of recording is still in beta mode, so it shouldn't be used in production networks, but hopefully it will be in full production very soon. And as I mentioned previously, one of my colleagues has written a fantastic document outlining exactly how you can spin up a root server in an environment where you've got virtual MXs peering to it in exactly the same way as we've done today in this video. Definitely worth a read through if you are planning to set this up. Thanks very much for watching the video. I hope you've enjoyed it and hope it's been useful. I shall catch you next time. Thanks, bye.